Well, we're live, and hello, everyone, and welcome. My name is Ricardo Camacho, and I'm the Director of Product Strategy for Embedded Safety Critical Compliance. And I'm excited to be here to host this fireside chat. Today, we're going to be talking to the leadership team behind Ribbit, where they have tackled one of the aerospace's biggest challenges, providing an autonomous flight system that is safe, certifiable, and reliable. And they're doing it faster by not starting from scratch. Actually, Ribbit took a bold approach. They retrofitted existing planes. They flew real missions under remote supervision and proved their system's safety step by step. This strategy is opening doors to rural, remote, and coastal regions where traditional aviations can't reach. So, in this chat, you'll hear about the teams, how they're balancing rapid innovation with safety critical rigor, how they embedded compliance into their workflow from day one, and turned certification into a competitive advantage, all while actually outpacing much of their larger competitors. So I'm excited to introduce the leadership team behind Ribbit. First, we have Carl Pigeon, the CEO of Ribbit. Carl's passion for aviation started early. He earned his pilot's license when he was just 17. And he holds a master's degree in aerospace engineering from the University of Toronto. Now, joining him is Jeremy Wang, Ribbit's COO. Jeremy holds a PhD in the mechanical engineering from the University of Waterloo, where he also serves as adjunct assistant professor. Now, Carl and Jeremy first met about 10 years ago while working on high-powered rockets at the University of Toronto. They later went on to design and test medium-sized drones in the UAV industry, an experience that ultimately inspired them to found Ribbit. Now, I'm also pleased to introduce Gareth Noyes, founding principal of No Yes Consulting, where he advises on software for critical edge infrastructure, embedded systems, and distributed cloud technologies. Now, with over 25 years of experience across aerospace, defense, and other industries, he previously served as Chief Strategy Officer at Wind River, helping guide its acquisitions by Intel and later Aptiv. Now, Gareth holds a PhD in high energy particle physics from the University of Birmingham in the UK. So remarkable stuff here. You guys, total intellectuals. Now, so we have some questions, and I'd like to start at the beginning. Now, Ribbit is tackling a huge challenge, connecting remote communities in Canada with autonomous air cargo. Now, Carl, what inspired you to take on this mission, and how do you see it fitting alongside other autonomous technologies like drones, eVTOL, or even self-driving cars, when it comes to real-world impact?
Yeah. So Ribbit was formed based off of, Jeremy and I being pretty value-driven. We wanted to work in an area that we love, to have an outsized impact to society, for the betterment of everybody. And so we wanted to pick a big problem. And we knew, aerospace was our passion. And given that we worked at a previous company that was building medium-sized drones, we started quickly realizing the limitations that they had in terms of their ability to carry payload and the distances that they could fly. And we also saw that there were challenges in general aviation with pilots on board. So we started talking to numerous customers. And one thing that became very clear was that when we talked to people in Northern Canada who have very poor transportation services, oftentimes things are late or they don't come frequently enough, or they're just extremely expensive. For instance, a watermelon in some of these communities is $50. So it's crazy, and we really want to make a difference. So that's where we came up with the idea of let's build an autopilot that could completely replace a human pilot so that we can retrofit these smaller aircraft, fit more cargo on board because there's no longer a pilot. And through that, we'd be able to provide quick and fast transportation to these communities. And since then, we've gone on to other markets like humanitarian aid and also the defense industry, where the same capability is required. And where we see kind of the differentiation between the other markets you talked about, I think every transportation mode has a certain application. And in our case, it's if you want something quick and to a destination that might be hard to reach, you want to use aviation or fixed wing aircraft in our case. And that's where we fit in.
Wow. It's also you're working with legacy aircraft, as you mentioned, fixed wing, like the Cessna 150 and the 206 to deliver, cargo under, these remote supervisions. So, why choose retrofitting existing planes rather than building new ones from scratch? How does that decision change the economics and the practicality of air cargo delivery?
Yeah. For us in the early days, it was a strategic decision. So realizing that a lot of companies that are just starting off die from implosion, not explosion. So choosing to do too many things at once is a quick path to give yourself a lot of pain later on. So we wanted to focus just on the autopilot aspect. And in doing so, we decided to use aircraft that already exist that we could quickly retrofit and prove out the technology. And so far, that's worked really well for us. There's certain downsides to that, and you have to be careful of what aircraft you choose. So, for instance, if it's an aircraft that is too old, where the parts aren't available for maintenance, that will affect your operations. So, it really comes down to understanding the market you're trying to serve and choosing the right aircraft for that market to retrofit.
Okay, thanks. Now, Gareth, from your perspective, Ribbit's approach of modernizing, proven systems is really interesting. Do you see other industries moving in the same direction, embedding autonomy into existing platforms rather than starting fresh?
Yeah, absolutely. And I think this is the golden era of software-defined things. For a long time, we've had automated systems, but there's been a fundamental shift to autonomous systems in the last decade or so. If I think I'm here in Silicon Valley, and it would have been, unthinkable for the automotive industry really to design a self-driving car from the ground up with the way they did things. So, I think what Carl and Jeremy are doing is very akin to what the Google X team did with autonomous driving, where they basically retrofitted existing vehicles with a data center. So, the first driving cars were data center on wheels, a lot of sensors, a lot of complexity of software, but really from a safety perspective, what the engineers were doing were reusing existing electromechanical systems and really focusing on some of the differentiated technology that didn't exist, whether it's pathfinding, sensor fusion, things like that. Now all of that has been really enabled by what I think of as sort of mass consumerization of really key important technologies. Think of cell phones haven't produced SoCs that have embedded GPS. They have micro electromechanical systems, MEMS for accelerometers and things like that. So you now have these consumer devices that are creating all these technologies that are absolutely foundational to autonomous systems. And what I see Ribbit do is really embrace and respect the existing infrastructure and think about what problems do you solve on top of that and integrate it in a way that from a system perspective is functionally safe, adheres to standards, and is conformant. So I see great parallels between your self-driving vehicles, autonomous robots, self-flying taxis, and what Carl and Ribbit are doing. So, yes.
Yeah. Technology is amazing, and it's moving so quick as well. So let's talk a little bit about the technical side. Jeremy, much of your innovation is in software. And so how do you balance moving fast with ensuring safety and certification? Are there areas where, you push the envelope and others where you deliberately, take a more cautious approach?
Yeah, that's a good question. I think probably best answered by dividing sort of long-term strategy versus near-term strategy. So, longer term, if you look at the areas that you and Carl already acknowledged, so these rural, coastal, remote areas, there's significantly less operational risk compared to other areas where aviation may function. So, lower air traffic densities, lower population densities, lots of alternate landing sites. And so whereas traditional aircraft certification takes a very product risk-centric approach, so often touted values like one catastrophic failure every 10 to the 9 flight hours, in our context, we look at the operating environment and we scale the risk acceptance and the safety requirements and robustness according to the environment. So because we're operating in these remote areas, we have our own set of operational risks that we need to manage, and those we discuss with Transport Canada, the aviation regulator, to make sure that they're met. So that's kind of the long-term perspective, taking advantage of the fact that these are hard-to-reach remote areas. In the near term, we have other mitigations. So, for example, Carl also doubles as our test pilot. So, as much as we believe in the technology, we also believe in having various layers of protections. And so there is often, when we're flight testing, the option to go back to a safety pilot that's on board the aircraft if we're flying in an optionally piloted format, as well as various other fail-safes. And so together, between sort of the near-term flight testing with a safety pilot on board, and longer term moving to fully remotely piloted all the time and in remote areas, kind of balance those two different, let's say, operational risk approaches.
Wow. So, also now when every, line of code matters, regulators like the Transport Canada, I'm sure they want solid evidence of compliance. And how does how does Parasoft's testing automation help Ribbit maintain the balance, meeting, rigorous standards like the 0178C without actually slowing down your innovation?
Yeah, so I mean, everybody knows the system safety assessment framework. So ARP 4754A kind of lays the groundwork for what safety looks like at a broader systems level. And then you also mentioned DO 178C, which applies to software assurance. Implementing those standards kind of in a way that is efficient, I should say, with a team that is relatively small and trying to move quickly is quite challenging. And the only way that it's really doable is if we integrate some degree of automation into the development process. So just like you have continuous integration delivery pipelines and automated software checks before code gets merged into the master repository, if you will, in sort of general software development, we apply the same principles through our software development life cycles, and Parasoft sits right in that life cycle. So it's not possible for members of our team to merge code unless it passes the standards and other types of checks that have been implemented through Parasoft. And all that's done in a really nice automated fashion. So in the early days, our team came together and said, what are the standards that are relevant? What are the standards what are the elements of the standards we want to implement and maybe customize for our specific application? So we make pretty extensive use, for example, of AutoSAR MISRA and the JSF C++ standard. And then Parasoft allows us to integrate that directly into our CI/CD system.
Yeah, fantastic. I'm glad we're a great team kind of helping each other here.
Yep, wouldn't be here otherwise. So.
So now, Gareth, one of the interesting things is AI is changing how code gets written and systems get, developed now. So how do you see aerospace and defense teams evolving to embrace innovation while still meeting these strict safety requirements?
Yeah, and I think Jeremy has laid out some of the frameworks, which is automation, high degrees of automation, and really allowing your tools and your processes to provide guardrails so that you don't do things that are stupid. It's much harder to fix a mistake later on than to either be prevented from making a mistake, or have a mistake that you're trying to remediate further down the line. So I view AI as being really fundamentally important in two areas, and I think there's a lot of focus on deployment of AI. Whether it's for image processing or things in an embedded device, and that's a hard thing from a regulatory perspective to certify. There's a lot of work being done at the FAA and NASA, for example, to understand exactly how conformance for those systems works. But I think one very immediate benefit of AI is in the development process. I mean, let's not forget that functional safety is as much about ensuring rigor around your development process. So define your safety argument, ensure that your requirement is specifying exactly what you're trying to do, and then validate, verify, and have that all be traceable. Now, that degree of automation on the development cycle with a sort of a DevOps pipeline and the augmented processes around safety argument is a great way to use AI to allow automation. I think there are certain areas, for instance, when you're doing a lot of strict static analysis, you can be overwhelmed by errors versus warnings. Some of these standards are very complex, and AI is very, very good at improving the signal to noise ratio there. So AI is a development framework that is your buddy for functional safety, in effect. And I think, ultimately there'll be a lot more focus on the deployment, but near term, I think for me, AI is really a sweet spot for automation, that functional safety side.
Yeah, so here at Parasoft, we're enhancing our tools. We're making the users a lot more productive through AI by prioritizing violations, by suggesting code fixes for coding violations and things like that. So it's really growing very fast, and we're actually very proud of how we're addressing the market and changing it as well. But, Jeremy, now autonomy naturally raises questions of trust. So how do you make sure your system are safe enough to fly without a pilot on board, while still moving quickly enough to innovate?
Yeah, that's always a fine balance. Definitely from a cultural perspective, our team is heavily biased towards testing. And so iterative testing is very much in our DNA. We can have cycles that are as fast as days to weeks in order to merge sort of new features into code. All depends on the nature of what's being built. But to stay true to the way that safety and risk management work in aviation, it is still very much a systems approach. So you start with requirements and risk. And like I said earlier, a big part of our approach is to emphasize where are the risks coming from? Is it product risk? Is it operational risk? And then sort of waterfalling it down as you would normally. And kind of the big element here is that if we want it to be fast, we can't necessarily rely on human coders, even especially when you have the independent verification requirements that come with sort of higher assurance levels in software. And so again, that's kind of where automated tools like Parasoft help with those checks, but also where AI helps too. So there's AI in the element of not AI on the aircraft per se, but AI assisting the design process, where again, having some degree of assurance on what the output is extremely helpful.
Now, thinking about the bigger picture, Carl, for communities in northern Canada or disaster-affected areas, reliable air cargo can be life-saving. So, how do you see Ribbit changing the way essential goods get delivered in the coming years? And are there lessons from your work that could apply to other autonomous domains like vehicles or drones?
Yeah, I think in the early days, autonomy is going to be very focused in these opportunistic communities that share the balance between risk and a deep need for the product. So like Jeremy said, in the northern and maritime communities in Canada is an example of that. So for them, it's going to be life-changing. They're going to get cheaper goods. They're going to be able to access more goods. Right now, the other problem is the selection of food, for instance, they have available to them is quite small. So where we see the impact for them is almost offering Amazon next day delivery to them effectively and opening up the market for them to access a bunch of goods at a cost-effective price. But long term, we really see this being a very substantial impact. You think of like back in the day when it was colonizing North America and we just had trains, every community was on the railroad train. But eventually cars came onto the market, more roads started being built, and we could connect communities with point-to-point transportation. And we see the advent of autonomy really being a similar transformation where we could take these smaller automated aircraft and remove your layover and you could fly between communities directly and faster. So that's really the dream that we're striving for. It's going to start in cargo, but eventually in time it will reach passenger transportation where the impact is going to be massive.
Wow. Okay.
Yeah.
So, Carl and Jeremy, now looking ahead 5 to 10 years, what excites you the most about the future of autonomous air cargo?
Yeah, I can start with that if you want. Yeah, sure. So for me, it's once we have the bigger vision implemented, where we're really connecting everybody with point-to-point transportation. I think it'll be really interesting to see what entrepreneurs decide to do with that new capability. So what businesses get built off of faster deliveries. Maybe commerce starts to change. I think there's a whole world of opportunity there that is not yet understood, but I'm extremely curious to see what will happen with our vision implemented.
Jeremy, did you want to add anything to?
Yeah, I would just tack on that. I think like when we started Ribbit, and Carl already alluded to this, we made it a point to try and talk to as many people as possible before we built anything. So we talked to retired school teachers, people working in grocery stores, those working for the airlines, pilots, mechanics, people impacted 2-3 degrees away from air transportation directly, just to try and really understand the context for the problem over and above the problem itself. And so I think the other thing that we're equally excited about is you have these untold possibilities that he just referenced right now. And then in the sort of near to midterm, the most tangible things we'll see are the direct improvements to standard of living and quality of life. It's like all of the major indicators of quality of life, be it income, education, life expectancy, otherwise, correlate very closely with access to transportation. And so although transportation itself is not a human right, all the other things are in many cases. And that for us, really, I guess, dignifies this mission that we're trying to pursue. And certainly we believe this is the most impactful thing we can do with our lives.
Mm-hmm. So, Gareth, from your vantage point in embedded and safety critical systems, what do you see as the biggest opportunities and challenges?
Well, what I really like about Ribbit is the mission-driven mindset and the societal impacts. And when I look around at autonomous systems, as you mentioned, I've been in embedded systems for 30 years. It was really a bit of a specialist backwater for a while. But with transportation modes, whether it's drone delivery, flying taxis, level 1 to level 5 autonomy in vehicles, autonomous sort of multimodal robotic systems on industrial floors, these are all going to have huge impacts on productivity, accessibility of services, and so they're really solving a bunch of different challenges. What I'm really excited about, though, is these new entrants, these different use cases, are really forcing a paradigm shift in the way that functional safety is addressed. I think that the classical model is do everything slowly, freeze your development. I mean, in aviation, you basically would like a fixed mode that you don't touch ever again. Changes are deemed to be, best avoided if you can. Now, I think the reality is with, more consumer-grade electronics in autonomous driving and, these fly-in modes, you're going to have to adapt that to more of an iterative and repeatable process that had to be certified. And I think that's the breakthrough that Ribbit is working on, and that things like Waymo and others are going to force is that mindset shift to adaptability while staying true to the foundation of functional safety. So it's a bit nerdy, but I'm really very, very excited about that concept. It's all about the processes, it's all about the automation, but it makes some of these dreams possible, and that is thrilling to me.
Yeah. So, Carl and Jeremy, if we fast forward 5 years, what do you hope Ribbit will have achieved?
Well, a ton. So we're working at a pretty fast pace. So we got new features coming online with our autopilot, mostly surrounding serving our customers in defense around teaming. There's a lot of discussions right now with everything going on in the world, and surely there's a need for it. But we also believe that these features will trickle down into the civilian market and humanitarian market as well. So in the aspect of teaming, for instance, if one pilot can control multiple aircraft at the same time, that will have an effect on reducing costs even further for our civilian customers. So there's a lot of good stuff going on, and you don't know, but maybe we'll see a scratch-built aircraft and no longer be retrofitting. So, but we don't have more details on that yet.
Okay, that's fantastic. And Gareth, how do you see AI? Or actually, Jeremy, I don't know if you wanted to add anything to that.
No, I think Carl covered it pretty well. There's a lot of exciting stuff in the works that you'll just have to keep an eye out for.
Yeah.
So Gareth, how do you see then AI and software development evolving in this space, and what will the next generation of safety critical systems look like?
Well, I think there are, as I said before, really two sides of the process side, and I think AI is going to provide a lot of automation around some of these processes and provide the guardrails. I think the more that we can understand, that the enforcement of rules, so being able to trace back to those rules and making sure you do nothing stupid. I think that's the biggest one. But clearly, I think when it comes to situational awareness, things in the flight environment, we already see some augmentation systems, not necessarily part of the core flight avionics systems, but aids around navigation, really things that augment the pilot's ability to focus on specific problems. And I think that's where AI is going to be a buddy to some of those systems. I think near term, it's going to be hard to have them at the core of the system. I think they're probably going to be augmentation tools, much like a lot of flight information systems can be done on iPads and other ancillary systems in a cockpit. And I think that's an area of scope for massive innovation. And it's all about reducing complexity and adding clarity to the pilot and the environment you're in. So there's a lot of promise of where AI can help there.
Mm-hmm. Yeah, amazing. So we actually have a few questions that have come in from our audience. So please, ask us questions. We'll start here with one of them. Hi, what is the difference between safety requirements, DAL levels, for autonomous cargo aircraft and commercial autonomous airplane in terms of certification? So
I could probably take that one. Okay. So I mean, kind of what Gareth was already alluding to is that as we move towards a new way of developing autonomy, which is to say one that is built around rapid testing and iteration, one that is adaptive, all of the existing functional safety sort of framework is still there. So the DAO level still exists, and I think the difference is more so in what are the criteria to meet the level of required mitigation for, say, a hazardous versus catastrophic versus major or minor sort of incident or event. And I'll give you an example. For example, the specific operational risk assessment, which is an international standard right now for operational risk assessment involving uncrewed or remotely piloted aircraft. There are different levels of reliability that apply depending on the risk level of your operation. So the definitions for functional safety, the idea of safety being a system property, the definitions of hazardous, minor, major, etc., those categorizations are still there. It's more so tweaking some of the quantitative requirements associated with those levels to be commensurate with the level of operational risk. Right? If you are flying in the middle of northern Canada, where in some places, Official Statistics Canada census information reports a population density of 0 people per square kilometer. You have lots of alternate landing sites, and you're less concerned about risks to the general public versus, for example, operating in downtown Toronto or New York. So the functional safety framework, everything still applies. It's just sort of tweaking it a little bit in the context of where we are operating.
Mm-hmm. Yeah, it's a tricky thing. You really have to do that analysis to determine what DAO level you're at and work to those requirements. So we have another question here. Would you operate within the current drone altitudes, or are you expecting air corridors to keep autonomous flights separated from traditional manned flights? Just one of you. Yeah.
Do you want to take that, Sean?
At a high level, so we'd be looking at operating as if we were a normal aircraft. So we operate under the framework of a special flight operating certificate, in which case you define your operating environment. So that could be a certain altitude that goes beyond the 400 feet limit for drones. But again, it all comes down to knowing the risk, knowing what environment you're trying to operate in, and quantifying the risk and your mitigation method for them. So Do you have anything to add to that, Jeremy?
No, it's basically, yeah, like it is the most accurate answer, even though it sounds like a bit of a cop-out, like it's kind of like, oh, it depends answer, right? But it's true, it really does depend. But, as a further example of that, like we're not necessarily going to be restricted to specific corridors, if that's sort of what the question is alluding to. Like it could be the case that there may be certain corridors where we will fly in. There may also be cases where it's sort of a more open airspace or sort of airspace region as opposed to a specific flight path. It very much depends on what the customer in the market calls for and how that then informs the requirements with Transport Canada.
Mm. And this is also all evolving as well. So, 10 years from now, it could look very different than what it does today in terms of how autonomous aircraft are implemented. I would expect that one day, 90% of the aircraft will be automated. But until then, I think we're in this messy middle where we do have to find solutions to both fly manned and unmanned aircraft.
That's it's amazing. So it's like a Waymo's kind of out and flying around.
Yeah,
I still haven't gotten into one of them.
They're amazing.
Yeah.
Now we've got another question. Have you or the regulatory bodies designed tests that if you pass those tests, your product is ready to be used with minimal or no supervision? Wondering how clear the roadmap is, or as this is a novel industry, everybody is just going one step at a time.
So our specific regulatory pathway is a bit of sort of what we consider to be our competitive advantage. So I can't go into all the details of it, but some of the more, let's say, general aspects that I think would be applicable to the person asking this question would be that yes, there are frameworks in place. So for example, like I said, one example would be the specific operational risk assessment framework, which is an international standard. The individual countries and associated aviation regulators, so Transport Canada, the FAA, EASA, et cetera, have their own implementations of what operational risk looks like. And then correspondingly, you can flow that down to individual subsystems. Like the collision avoidance system will have specific requirements on detecting aircraft, initiating avoidance maneuvers, doing so in a way that is sufficiently fast from a compute perspective. So I would say the roadmap, although in terms of time, has not been defined. Like no regulator has committed to a specific time frame when certain vehicles of a certain size will be allowed to operate widespread without anybody on board. I would argue that the risk philosophy has been established, and it's up to the applicant, meaning the companies or the researchers interested in doing the work, to approach the aviation regulator and sort of look at, here's the type of aircraft we want to operate, here's where we want to operate and what we want to carry as a payload. And then sort of work it backwards from their specific situation. So I would say elements of the roadmap are there.
Yeah, you guys are kind of pioneering all of this too as well. So that's kind of good. Now, got another question here. Is our last question? If anybody, please add any questions you want. Hi all, thank you for sharing your insights in this autopilot designed for a specific plane. Oh, is this autopilot designed for a specific plane? And if yes, how easy would it be to retrofit it to another, either a simpler model or a much more different one, such as a large cargo plane?
Right. Yeah, it's built to be aircraft agnostic, meaning we can fit it on any aircraft. We built it on the insight that when we initially experimented with these small autopilots like ArduPilot, et cetera, that it just wasn't sufficient for a bigger aircraft with different flight dynamics. So we've built it for kind of the 1,000-pound and up aircraft in terms of gross weight. And there's certain mechanical installations you have to change when you go to another aircraft. But in general, the architecture is built so that it can be used on any fixed wing aircraft.
It's amazing.
So I guess the technology is kind of similar, or all the parts and pieces are kind of there, so it relates, and you can, okay. Wow.
Yeah, it's like a building block almost. And just like a pilot can fly many different types of planes, so can ours.
Okay. Well, we don't have any more questions. We're already at 35 minutes. So this discussion actually shows that with the right approach, small teams can outpace actually the larger competitors out there. and deliver real world impact. And you can also build trust with regulators and customers. And it's exciting to imagine that Ribbit and you guys' autonomy in aviation will actually achieve. Wonder what it'll actually achieve in the next 5 to 10 years. Anyways, I really thank you, Carl and Jeremy and Gareth, for sharing your expertise and vision with us today. And we're also receiving just one more question came in. Thank you for your time today. My question is Ribbit planning on being the operator of the cargo business, or are you looking to sell the capability to existing cargo flight operators? So sneak that one in there.
Sure. We leave that option open right now. It will depend on the customer themselves. So whether it's a civilian or defense or humanitarian, each have their different needs, and we'll look at addressing them accordingly.
All right. Well, thank you, everybody. Thank you, Jeremy. If you guys have any last words you want to state, please. The forum is open.
No, without trying to score too many brownie points, I mean, we really enjoyed working with you guys at Parasoft, and the product's been extremely helpful. Like, we again, going back to the philosophy of trying to be fast and adaptable and having this emphasis on testing, we try to use commercial off-the-shelf where possible. But that also means that those off-the-shelf solutions have to be extremely reliable. So we're really fortunate and grateful for this partnership that we have.
Well, thank you very much. And it's been a pleasure for us as well, from Parasoft. We love working with you guys, the Ribbit team, and we're really looking forward to your success in the business.
Yeah,
and we're happy to help.
Nice.
Thank you.
Appreciate it.
Okay.
Bye, everybody, and thank you.
Take care.
Thank you.
Bye now.